Hello and welcome, students. My name is Shampa, and today we are going to convert exponents into standard form. We will convert very big numbers into standard form and very small numbers into standard form. Let's see how to do it, and we will also learn why do we need to do it. So, let's begin. So, do we all know what is the speed of light? Yes, we do. It is 300 million meters per second. We know that this number is quite big, but it is still, we can still comprehend it. It's not very easy to present it, but we can still understand this number. It's not that hard. We can convert it into 3 lakh kilometers per second. That way it becomes readable and it becomes presentable as well. We can comprehend this figure. We can comprehend 3 lakhs per second. So this is good. But what about the mass of the earth? Do we all know what the mass of the earth is? So this is the mass of the earth. Can you count the number of zeros that are followed by 5976? Let me tell you. We have 24 zeros followed by 5976. This is quite a big number. So there has to be a way so that we can express this number in a way that can be understood by people and that can be written and expressed. So that is why we convert numbers into their standard form. Let's find out how do we do it. Let's take the example of this number 3000. We can read it, we can express it easily, we know that. But we are taking this small example so that it is easy for you to understand the concept of standardization of exponents. So let's begin. So what we will do is, we will consider this part, this number, the number on the extreme left. What we will do is, we will truncate this number, we will keep it separately, put a decimal, and we will write the remaining numbers behind the decimal, and this number will be ahead of the decimal. But you will tell me this is wrong. How can we do that? Isn't there any difference between 3000 and number 3.000? Of course there is difference. What we did just now is, in order to convert 3000 into 3, we divided 3000 by 1000, right? Now that we divided a number by 1000, in order to do justice to the number, we will have to multiply the number to 1000 as well. Now this is fair. We divided a number by 1000 and we multiplied the same number by 1000. So now this is justice. This is fair and this is something that is acceptable in mathematics. So, I'm sorry, actually not this number. We divided 3000 by 1000 so that we can put the decimal here, and because we divided it by 1000, we multiplied it by 1000. Now, because we divided 3000 by 1000, so this 0 will cancel out with this 0 will cancel out with this 0, and this 0 will cancel out with this 0. So it will remain 3 into 1000. Now you will tell me that we have got the same thing. 3 into 1000 is 3000. So what a big deal. What is it that is different that we did? Well, we can express it as 3.0 into 10 to the power 3. 1000 is nothing but 10 to the power 3. Now this is the standard form of expressing very large numbers. You must be wondering, This is such a small number. What is there the need to change this number in to 3 into 10 to the power 3? Well, we don't use this property of standardization for such small numbers. We do it for very large numbers, like the speed of light or the distance of Alpha Centauri from Earth, or the mass of the Earth. They are very big numbers. So let's move on. Now let's quickly revise the concept we have just learned. We have this number. This is 70 lakh 24,975. First step is we will consider the number that is on the extreme left. Why? The number on the extreme left is always considered, and the number on the extreme left should have a value between 1 and 10. If it is 1, it is considered. If it is 10, it is not considered. It is 7, so we can consider it. So it's important to know what is going to be the end result. We want a number like this. 7, the whole number part should be 7, and there should be a decimal, and the rest of the numbers should follow the decimal. This is the end result that we want. Okay. Now, in order to convert this number to this number, let's see what we will do. We have behind 7, we have how many places? Ones, tens, 100,000, 10,000, 1 lakh. So, what we will do here is we will divide it. So the decimal part is here. Decimal part is here. We can put as many zeros as we want. So we want to bring this decimal from here to here. So how many places it will jump? 1 place, 2 place, 3 place, 4 place, 5 place, and 6 place. So let's write the number neatly here. 7024975. So this decimal place will jump 1, 2, 3, 4, 5, 6. 6 places. So in order to bring this decimal from here to here, we will divide it by 10 to the power 6. Or you can simply say 10 lakh. For the sake of convenience, I wrote 10 to the power 6 here. Now that we divided the number by 10 lakh, in order to keep the number same, we will multiply it by 10 lakh. That's fair. 10 lakh or 1 million, whatever you call it. So now, because we divided the number with 10 lakh, it will jump here 1, 2, 3, 4, 5, 6. So this number will become 7.024975. Now this figure has been utilized in the conversion of this number from 70,24,975 to 7.024975. And we are left behind with this number and this 10 million. We will express it like this. This is 10 million. So this number, this big number, 70,24,975, can be expressed in the standard form like this. 7.024975 into 10 to the power 6. So this is the standard form. Now let's understand it with the help of the mass of the earth, right? Now look at this figure. This is the mass of the earth. 5,976 followed by 21 zeros. It's very inconvenient figure and it is not easy to express this figure whenever we want to do any sort of calculation. So let's convert it into its standard form. In order to do that, we have the decimal here and we want to bring it here. Students, we know how to convert a number into its standard form. We extract the number that is on the extreme left, and this number should have a value between 1 and 10. So this number has a value of 5, so this is acceptable, and we want to bring this decimal from here to here. So how many places do we have? How many places this decimal will have to jump? Let's find out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So that means we will have to divide 59760 by 10 to the power 24. If we do that, this decimal place from here will jump to here. So this part will be utilized to bring this decimal place from here to here. And because we divided it by 10 to the power 24, we will multiply it by 10 to the power 24 so that the number remains unchanged. We know we can multiply the numerator, and if we multiply the numerator and the denominator by the same number, the number remains unchanged. We know the rule. So finally we have got 5.976. These zeros are optional if you want to put them, but that they are not needed. We don't have to write them, that's why we are converting this number into the standard form. So let's not write them. You can write them, it won't matter, but let's not do it for the sake of simplicity. We have 5.976 into 10 to the power 24. This is the standard form of the mass of the earth. Is that clear? Now let's move on to the conversion of small numbers, very small numbers, into its standard form. Now this is the size of cells inside our body. We know what cells are. Cells are the basic structural and functional unit of life. I know this is not biology class, but I must mention it so that we know what we are going to study. So micrometer, what is micrometer? Micrometer is something like, if we say the size of a cell is 10 micrometer, it means 10 will be in the numerator and we will have to divide the denominator by 1 million. Then this is the size of the cell. It is that small. Now, this figure, if we convert it, here we converted it into decimal fraction. Let's convert it into decimal fraction. Let's see what we are going to get. So we have this decimal place here. So this will become, so this is 0.00001. This is the size. This is the, I should put the unit here. Without the unit, it is meaningless. So this is the size, normally the size of a human cell. So this number, in order to give an idea what this number is, and in order to make this number presentable, let's convert it into its standard form so that we can present it in a way that can be understood easily. So let's take an example. Now this is the size of a bacteria. This many micrometer. Now we would like to convert it to a standard form. It's not easy to express this number all the time, so let's do it. We have the decimal place here and we want this decimal place to be here. Why? So that we can present it in a way that can be understood. So in order to bring this decimal place from here to here, what we are going to do? We will have to multiply. This time we will multiply. Last time we divided, it was a big number. So we will have to multiply it by 1 place, 2 place, 3 place, 4 place, 5 place, 6 place, 7 place. So we will have to multiply this number by 10 to the power 7. If we do that, this decimal place will come here. From here, this will come here. Now that we multiplied it by 7, we multiplied it by 10 to the power 7. So we will have to divide it by 10 to the power 7 as well. So this numerator part will be utilized in the conversion. So we have 5 into 10 to the power. 1 second. This part, this 10 to the power 7 part has been utilized here. So this will become 5 into 1 by 10 to the power 7. Now we know this denominator part 10 to the power 7 can be written like this. So this number, this is the standard form of the size of this bacteria. So this is 5 into 10 to the power minus 7 meters. This is convenient. I'm sorry, this part is not micrometers, this is meters. Let's move on to one more question. Now this is normally the thickness of a paper, 0.07 millimeter. Let's convert it to its standard form. In order to do that, we have to bring this decimal from here to here. Why do we do that? Because a standard form should start with a whole number and the whole number part should contain number from ranging from 1 to 10, where 10 is not considered but 1 is considered. So we will try to convert it into 7 into some decimal place. We will look into it. 0.07. In order to bring this decimal place from here to here, we will multiply it by 10 to the power 2 and we will divide it by 10 to the power 2 as well in order to keep the number unchanged. This numerator part will be utilized here. So this number will become 7 into 1 by 10 to the power 2, which is 7 into 10 to the power minus 2. So this is the standard form of this number, 0.07 millimeter. I'm sorry, I forgot to write the unit here. It's very important to always mention the unit, otherwise we won't know what we are dealing with. So let's move on. Now this is the diameter of the sun. So let's convert it into its standard form. We have the decimal place here. 1, 2, 3, 4, 5, 6, 7, 8 and 9. We want to retain this one. So we want the decimal here. Okay. So we will divide it by 10 to the power 9 so that we can bring this decimal from here to here. And we will multiply it by 9 again in order to keep the number unchanged. So we have 1.4 into 10 to the power 9. This is the diameter of our sun. let's convert 1 micron to its standard form. 1 micron is equal to 1 by 1 million. We know that. Now, in order to convert it to its standard form, what we will do is this. We already have this whole number part. We don't have to do anything here. And we have 6 zeros. As a decimal fraction, we have 6 zeros here. So it is 1 by 1 million. So we can write it as 1 into 10 to the power minus 6 meters. This is the representation of 1 micron. So that's it for today's session. See you in my next session. Till then, please take care of yourself and you have a good day.